Welcome to this Wisel Excel VBA tutorial. In this video we'll explain how to execute basic ADO commands using SQL Server. We'll begin by reminding you how to return a set of query results to a record set using the fairly standard approach of setting the source of the record set to refer to either a table name, a select statement or a store procedure. We'll then look at how we can achieve exactly the same results by using a command object. We'll explain a couple of the benefits of doing things that way, such as being able to set the command type. And then we'll move on to executing commands which don't return a set of results. We'll explain how to use the insert into, the update and the delete from statements in SQL. We'll have a couple of extra features such as how to check the number of rows affected by the statements, and also a quick mention of how to optimize the execution of a statement which doesn't return a set of results. So let's get started. Okay, to get started there are a few things you'll need. First of all, a copy of the files I've created for this session. I'll stick a link in the video description below so that you can download this folder, and when you've extracted that, you should find it contains a couple of basic SQL script files. You will also need access to an instance of SQL Server, and if you haven't already installed that, we do have a couple of different tutorials which explain exactly how to do it. There's one for SQL Server 2017 and a separate one for SQL Server 2016. I'm going to be using the latest version of Microsoft's OLEDB driver for SQL Server, and that requires a separate installation. It's not very difficult, it's a quick download of about 5 megabytes and a very simple little wizard to get that installed. If you did want a little bit of help with that, we do have a separate video which includes how to install it, the first part of this little mini-series on connecting to SQL Server using ADO. So assuming you've got all that done already, what I'm going to do now is head into SQL Server Management Studio. And what I'm going to do is execute the first script file to create a copy of my movies database. So I'll choose to open up an existing file, and then I'll point to the folder of extracted files and open up file number 1, create movies database. All I need to do then is execute that, and it shouldn't take too long. And eventually I should get a little message indicating success. There we go, query executed successfully. If I just expand my databases folder, I might need to refresh that folder in order to see the results. So I can right click on databases and choose refresh. And there's my movies database sitting there. I'll also need to have access to a store procedure just for demonstration purposes. So I'm also going to open up the other script file at this point, file number 2, create list actors procedure. It's not a particularly complicated one, it's just a basic example for demonstration. And if I execute that as well, I will now end up with a store procedure sitting in my movies database. If I expand the movies database and then expand the programmability folder and then the store procedures folder in there, there's my store procedure called list actors. Okay, setup done. We can now head into Excel. I've just created a brand new blank workbook. From there I'll head to the Developer tab, open up the Visual Basic Editor, and then insert a new module ready to get started with some code. We'll start with a quick reminder of how to get data out of a database using a simple Recordset object. So let's begin a new subroutine. Let's call it Get Data using Recordset. And then just to give us a bit of help with writing the code, we'll set a reference to the Microsoft ActiveX Data Objects library. So we can head to the Tools menu at the top of the screen and choose References. And then when the dialog box appears, we can scroll down through the list to find the Microsoft ActiveX Data Objects library. I'll go with the latest version I have available, which is 6.1, and if I check the box next to that and click OK, I'll now get a bit of help in the IntelliSense when I do things, for example, like declare a variable to hold a reference to a connection object. So I'll say dimcn as adodb.connection. While I'm here, I'll also declare a variable to hold a reference to a record set object, so dimrs as adodb.recordset. What I'll then want to do is create a new instance of the connection class. So I can say set cn to be equal to a new adodb.connection. And then there are several properties of the connection object I want to set, but the most important one is the connection string property. So cn.connection string equals. Now the exact connection string you type out will depend on which instance of SQL Server you're connecting to and what database you want to connect to and so on. But for this example, I'm going to go with a fairly standard one. If you've watched a few previous videos, this will be fairly familiar to you. I'll start by specifying the provider name, which in this case is MS OLEDB SQL. That's the name of the new one that I pointed out you'll need to install. And then I'll concatenate to this, just so that hopefully you can read the entire string. I'll concatenate the server name. So I'll enter the server property server equals. Now in my case, I'm referring to a local instance of SQL Server. So I'll refer to my local host, followed by a backslash. And then I have a named instance, which is called SQL 2017 training. I can then enter a semicolon there, close the double quotes, and then concatenate to that the name of the database that I want to connect to. So that's nice and easy as well. Database equals movies. I'll stick a semicolon then and concatenate to this with another new line. And finally, for now, we'll say trusted connection equals yes. And this is to indicate that I'm connecting to a Windows authenticated SQL server and passing in my Windows credentials to connect to it. So just to make sure that that connection string is configured properly, what we should do at this point is try to open the connection and then provide ourselves with a few blank lines and then say cn.close. If I step through the procedure using the F8 key, if I can open and close a connection without any errors, that's a good sign, indicates that my connection string is set up properly. Now, if you've watched the few previous videos in this series, you'll be familiar with a fairly standard way of opening a record set object. We've done things like set rs equals new adodb.recordset to create a new instance of that class. Then we've set a few of its properties. We've said rs.activeConnection equals cn. We've said rs.source, and then in there we've provided either the name of a table or an SQL select statement or even the name of a stored procedure. In this case, I'll just refer directly to the actor table in my database. So I'm going to refer to the DBO schema followed by .actor. We've then also optionally set a couple of properties to do with the cursor type and lock type. So we've set rs.cursorType equals, and then we've gone for AD open forward only, which is the quickest one to use when you only want to make one pass through the records. And then we've also used rs.lockType equals AD_lock read only, as we're not modifying any data. At that point, we've then said rs.open, and then we have access to all of the records in there. A little later on, we've said rs.close. And then again, just to quickly test that this now works, if I use the F8 key to step through, this all works in a fairly straightforward fashion. When I open the record set, I get access to the data, and then I close the record set, close the connection, and then end the subroutine. Now, there is a slightly quicker way to generate a new record set object without having to explicitly create it and then set all of its properties. Rather than saying set rs equals new adodb.recordset, after opening the connection, I can simply say set rs equals cn.execute. If I just open some parentheses at the end of that method name, you'll see that at the end of that, it says it returns a value or a reference as a record set. All I really need to do here is pass in the command text as string, and the simplest possible thing I can do here is just refer to my table name. So if I just copy that string, dbo.actor, and then close the parentheses, the remaining lines that I've entered here, I can either delete entirely or just comment out. So for the moment, let me just comment them out. And then if I use the F8 key to step through, we will see this time that when I perform this instruction, set rs equals cn.execute, that returns a record set, an open record set. It uses the connection that I've applied the execute method to, so I don't need to say rs.activeConnection equals. The source is passed in via the command text, and the default cursor type and lock type are AD open forward only and AD lock read only, and the execute method returns a record set with that cursor type and lock type. I don't even need to say rs.open because the execute method opens it automatically. So it's a much shorter, simpler, easier way to return a basic record set, applying the execute method to the connection object. Let me just close the record set and close the connection and end the subroutine. And then just for the moment, I'll delete all the code I commented out, and then we'll proceed with this basic version of the code for opening a record set. Now, at various points in the video, I'm going to want to write out the results of my record set into a new worksheet. So let's take the time just to quickly create a new subroutine to help us with that. Let's create a sub called write, I'll spell write properly, write results to sheet. And then we'll declare a parameter here, let's call it result set, as an adodb.recordset object. Record set was what I was going for, there we are. Then a couple of basic things we'll need to do. Let's declare a variable which can hold a reference to a worksheet object. So dim ws as worksheet. And then I will set ws to be equal to worksheets.add. So that will add a new worksheet to the collection of worksheets in the active workbook. You may be familiar with the little bug that occurs if you don't select the worksheet before copying the results from the record set into it. So we described that in previous videos in this little series. So just to make sure that that doesn't affect us here, we'll say ws.select. The simplest way then to get the data out of the record set is to refer to a range on that worksheet. So let's say ws.range_a2.copy from record set and then refer to the result set parameter. Anything else we want to do in terms of tidying up? So for example, getting the list of column names at the top row of the worksheet. We can do this in a couple of different ways. What I'll do here is I'll declare a variable called f as an adodb.field, and annoyingly that doesn't appear in the IntelliSense, and again we explained why not in a previous video in this little mini series. Just hit the escape key, just accept that field definitely does exist. And then before we copy the data from the record set, we can say for each f in, and then we can refer to the result set parameter and then the fields collection in there. A couple of blank lines and I'll say next f. What I'll then want to do is keep track of how many fields I've processed. So let's declare another variable, let's say dim I as integer. And then inside the for each loop, I can keep track of how many fields I've processed by saying I equals I plus 1. Then what I'll do is refer to the worksheet's cells property and then refer to row number 1 and column number I, so refer to the value held in the variable, and then I'll set the value of that cell to be equal to f.name. Just to finish off, we'll change the column width. We'll say ws.range_a1.current_region.entire_column.autofit, and that will make sure that all the columns in the worksheet are the correct width to display all the data we've copied. Let's give that a quick test then. So after we've created our record set down here in the get data using record set method, we can make a call to the write results to sheet. We can pass into it the reference to our record set variable. And then if we simply run this subroutine, we should find we get a brand new worksheet. And if I look in the worksheet, I'll get all the data from the actor table. Now, as well as just referencing a simple table name, you can also write select statements or refer to store procedures in the execute method of a connection object. So let's head back to the Visual Basic Editor and let's just create another version of our setRs statement. We'll say setRs equals cn.execute, and then this time let's write out a basic select statement. I'm going to select a few specific columns from my actor table. I'll say select first name. In fact, what I'll do first is select actor ID and then comma first name, followed by another comma and then family name and then another comma and the DOB field. I'll select those fields or those columns from dbo.actor, and I'd like to change the order of the results so that the most recent actor added to the table sits at the top of the results. So I can say order by actor ID, I'm just going to run out of space on my screen at this point, by actor ID DESC. If I close the double quotes in and close the round brackets, that's the complete select statement. Let me see if I can bring this down to a separate line so you can see the entire thing in one screen width. If I were then to just comment out my cn.execute dbo.actor version of that line, I can run the subroutine again and I'll end up with another new worksheet, but this time I've got a different set of columns and my actors sorted in a different order. Finally, I could also just refer to a store procedure if I have one available, and the store procedure we just created was called list actors. So what I could do here instead, if I just head back to the Visual Basic Editor and if I comment out these two lines, I'll then just make a copy of the original one that referred to a table name and then replace the reference to the table with a reference to my list actors procedure. So having done that, I can run that subroutine again and I'll end up with another list of actors, this time produced by the results of a stored procedure. Now there is another way you can get data into a record set, and that's using an ADO command object, which is really the focus for this video. So let's head back into the Visual Basic Editor, and let's make a copy of our subroutine called Get Data Using Recordset. I copy that entire thing and then paste it in immediately below. I'll say get data using, let's call it command this time, so get data using command. We will still need a record set object, but we'll also declare another variable called, let's call it cmd as adodb.command. After we've created a new connection and opened it, what we can then do is create a new command object. So we can say set cmd equals new adodb.command. We can then configure a couple of its properties. So for example, we can say cmd.activeConnection, just like we did originally with a record set, equals cn. We can also set the command text of the command. So we could say cmd.commandText equals, and this is simply a string. Now the strings you can enter here are exactly the same as those that we can pass to the execute method of the connection object or to the record set source property. So let's start by referring to dbo.actor. If I just copy that from the other code I had there. What I can then do is a little later on, let me just comment out the set rs line there. I'll just keep those in there for the time being. After I've set the command text of the command object, I can choose to execute it. So if I say cmd.execute, followed by a space, you'll hopefully see at the end here, after I've executed the command, it also returns a record set object, just like the execute method does for a connection object. So I can use the exact same technique. I can say set rs equals cmd.execute, and that will generate a new open record set with the forward only cursor and the read only lock type, and I can then pass that record set to my write results to sheet method. So if I simply run this subroutine, I will end up with another new worksheet with exactly the same list of results as my first example using a simple record set. I could modify this again, so rather than passing in the name of my table, I could set command text, so cmd.commandText equals, and then I could write out my full select statement. So let me just copy and paste that from a previous instruction to avoid writing it all out again. And then I can just comment out the one that references the table, and then I can set my record set to be equal to the results of executing the command. If I run the subroutine again, I'll end up with the same results I saw earlier on using the record set. And then of course, you've probably guessed, you can also set the command text to be a stored procedure. So if I say cmd.commandText equals, and then refer to my dbo.listActors stored procedure. I'll comment out the one that uses the select statement and then execute the subroutine one more time, and then we should see that we get the exact same list of results one more time from the stored procedure. Now so far all we've managed to do with our command is achieve the same end results in a slightly more complicated way, but there are some advantages to using a command over and above the basic execute method of a connection object. First of all, we can optimize the command by specifying its type. Let me just quickly tidy up before I show you how to do that. Let me take away these commented out lines referring to my record set, and then just clear out the rest of those blank lines. And then I'll do something similar in the workbook as well. Let's head back to the workbook. Then let's just delete all the extra worksheets apart from sheet 1. I'll then just right click delete and then confirm that I want to do that. And then what I would like to do is say, rather than just cmd.commandText equals the name of my store procedure, I'm going to indicate to the command that its type is a store procedure. So I can say cmd.commandType and then make this equal to ad command stored proc. Now, with such a small example, you won't notice any difference, but it does optimize the processing of that command. And if I run the subroutine at this point, I'll end up with yet another version of the same set of results, my actors listed in descending order of ID. For the other types, again, it's fairly simple. If I just comment out those 2 lines, I can bring back my command text with my select statement. I will then say cmd.commandType equals, and then I can say ad command text. And again, if I run that subroutine, it would give me exactly the same set of results as I've seen previously. And then I can head back, and again, if I comment out these 2 lines, if I wanted to specify that I'm referring to a table name, I can set my command type to be equal to a table. So cmd.command type equals adcmd table. And just to make sure we've demonstrated every one of the options, let's run that one again. And again, we get now the full list of results from the actor table. Another useful thing about using a command object rather than just setting the source property of a record set is that you can use a command object to execute statements that don't return a set of records. To demonstrate that, we'll insert some new data into the actor table. Let's just copy the entire procedure we've just finished writing, the get data using command subroutine, and then we can paste that in at the bottom of the module. At this point, we'll change the name of it. Let's say something like add data to table using command. Then there's a few things we can get rid of here. First of all, we won't need a record set variable at all, so we can delete that entirely. We can also then remove the statement that says set rs equals command.execute. We'll leave the command.execute part in there, just remove the section that refers to the record set. We can then remove the line that writes the results to a sheet because we won't have any results to write. And then we can also remove the line which closes a record set, as we'll never open one in the first place. Let's also remove a couple of these statements here. Let's remove the commented out command that calls on our store procedure. We can remove that one entirely. And then we could also remove the one which uses the table name. Let's remove that one as well. Okay, so that leaves us with the command type, command text, which is what this command type will be. So we can uncomment that line, and then we can work out how to set the command text to allow us to insert a set of data into our table. To do this, we'll use an insert into statement. Rather than write the entire thing from scratch, let's use the select statement to help. Let's bring this down onto a separate line first of all. And then we can replace the select keyword with the insert into keywords. Following that, we need to specify the name of the table we want to insert a record into. So let's just copy the table name and its schema name from later on in the select statement, and then paste that in after the insert into keywords. We'll then need to specify which column names we want to populate in a set of round brackets in a comma separated list. So let's open up some round brackets or parentheses. We can't populate the actor ID in this case. The actor ID is configured as an identity column, so that means it will automatically be assigned a number whenever a new record is inserted. So let's remove the reference to the actor ID field. Then we can refer to the first name, followed by a comma, then the family name and a comma, and then the DOB field. We can then close the round brackets at that point, and again, just to make life slightly easier, I'll stick a space in there, then close that string, type in an ampersand and then the continuation character as an underscore, and then bring the rest of the statement down to the next line. Now we've already specified which table we're inserting our record into, so the from clause is unnecessary and doesn't work in an insert into statement, nor does the order by clause. So let's remove those. What we'll do here is replace that with the values keyword, and then in a set of round brackets, we can write the comma separated list of values we want to populate this list of columns. So in a set of single quotes, let's say for example we want to insert wise owl as an actor into the actor table. We can type in the word wise in a set of single quotes, followed by a comma, and then owl in a separate set of single quotes, and then another comma. And then finally, a valid date string. So in this case, what we'll do is open up some single quotes. Wise Owl started in 1992, unbelievably, such a long time ago. And we need to specify both a year and a month and a day. So let's use the month and day of today's date. So -06 for June, -24 for the day of the month. We can then close the single quotes and then close the round brackets, and then the entire string is completed with a closed set of double quotes, and that's our basic insert into statement written. Now let's run the subroutine to insert wise owl into the table. So we can just run the subroutine. We don't get much of a clue that anything's happened. So if we wanted to be able to see the results of this, we'll need to retrieve all the results from the actor table, preferably sorted in descending order of actor ID. So let's head back to the previous procedure. Let's just comment out the command table referencing DBO actor, that will just bring out the actors in there in the order they were added to the table, and we wanted that to be reversed. So we could do this either with the store procedure or with our select statement. Let's uncomment the select statement, and then we can run this subroutine. And if we switch back to the workbook and have a look at the list of records, we'll see that YSL is sitting there right at the very top. You can also pass in multiple sets of values to the insert into statement fairly easily if we switch back to the Visual Basic Editor and then scroll down to the Add Data to Table using command subroutine. Let's extend our insert into statement by adding another ampersand and a space underscore to continue on the next line. Then if I open and close a set of double quotes there, what I'm going to do is just copy the set of values in parentheses from my original statement and then paste those in on the next line and then stick a comma in just before it. So you can basically write a comma separated list of parenthesized comma separated values. I don't want to add YSL again another couple of times, so in this case, let's think of some alternative names for YSL. We could go with that. We could maybe change YSL's name to Clever Cat instead, or we could call it Brainy Badger. Oh, sorry, I misspelled that. Brainy Badger. There we go. That's a much better name for YSL. And then let's go with one more as well. Let's just copy this line all together, and then we can concatenate this with another underscore. Paste that in, and then let's call this one, let's go for Astute Aardvark. All far better names than YSL, I'm sure you will agree. So if I run this subroutine at this point, and then once again return to my previous subroutine to retrieve a set of results, we will see that our new set of results contains those wonderful 3 new names for YSL. When you execute a statement like this, which affects multiple records, it can be useful to obtain information about how many records were affected. So to do that, let's switch back to the Visual Basic Editor and scroll back down to the Add Data to Table using a command subroutine, and let's declare a variable which can capture the number of results. Let's say, I'm going to call this one num_rows, and I'll set the data type to long. What I'll then do is scroll down to the command.execute statement, and then if I type in a space immediately after the execute method, you'll see the first parameter name there, an optional one of course, but the first parameter is records affected. Now this works in a slightly odd way. If I say records affected, ordinarily what you do with named parameters is you pass a value into the parameter. What we're really doing here is we're extracting a value from it instead, so this is more like an output parameter. So I want to set the records affected parameter to be the name of the variable I have just declared. Once I have captured that number, I can then present that back to the user somehow. Let's use a basic message box. You have inserted, I'll spell have properly eventually, you have inserted, and then I can concatenate the num_rows variable, and then I can concatenate the name or the word record or records. Let's be clever about it. Let's say records with an S in some round brackets there. I'll also display an information symbol on the message just to make it look a little bit more official. There we go, VB information. Okay, so I am going to insert what I think will be 3 records with my values list there. So if I run my subroutine again, this time I get a piece of information that tells me how many results I have returned. Now, of course, I have essentially inserted duplicate values into my table. That's okay for the time being. If I click OK, just to demonstrate that, if I switch back to the previous subroutine, the one that gets the data using the command object, if I run that subroutine again, my new output now will have 2 copies of the extra names for YSL. Now let's look at how we can modify existing data in a database. As everybody knows, dogs are much better than cats, so what we'll do is we'll update any record where the family name is cat to be canine instead, so we'll have clever canine rather than clever cat. To make that work, what we can do is head back to the Visual Basic Editor, and I think this time what we'll do is we'll copy our entire Add Data to Table using command subroutine. The basic structure will be the same, it's just the actual statement itself that will differ. If we were being clever about this, we'd probably create a separate procedure which accepts a string value so that we can pass in different statements to the same procedure multiple times. But just for demonstration purposes, I'm going to copy the entire subroutine, and at least you'll have a record of all the different examples we've created together in the video. Let's call this one modify data. Sorry, that was meant to be modify, not odify. Modify data in table using command. Then what we need to do is change our insert into statement into an update statement. So let's start by changing the first line. This is fairly straightforward actually. All we need to do here is say update followed by the name of the table, dbo.actor. On the next line, what we can do is say what values we want to set, which columns we want to set to which values. So to do that, we can use the set statement. We can say set family name to be equal to, and then we're going to put in the word canine. So the word canine goes into a set of single quotes as its literal text. Now, with that statement, if that was the entirety of the statement, update table actor setting the family name to canine, that would change every single record's family name to canine. And we only want to do this when we're looking at a record whose family name is currently equal to cat. So what we'll do next is add in a where clause, similar to the where clause you can add in to a select statement. So in this case, we'll say where family name equals, and then in a set of single quotes, the word cat. Now we don't need the rest of the statement, this extra fourth line, so let's remove that one entirely. There's our entire update statement written. We'll execute the command and then again return the number of rows affected. So this is kind of helpful to see how many records we've changed. We'd expect it to only be 2. So let's hope that that's the case. If we run the subroutine at this point, we do indeed. It says we have inserted. I should have changed the message to say you have altered or modified or updated 2 records. So if I click OK at that point, if I were to return the set of results, if I switch back up to my subroutine, which gets data using command, let's get another set of data. We'll see this time, rather than clever cat, we've got 2 clever canines instead. If I switch back to the Visual Basic Editor and head back down to the bottom of the module, let's just change our message box to say that you have updated rather than inserted. Now this time, because all of our cats have already been modified, if I run the subroutine again, this should return 0 rows affected. So you have updated 0 records, exactly as we would expect. Okay. For the final example, let's have a look at how we can delete some data from the table. If I switch back to the workbook, let's say we've done a bit of focus testing now, and maybe people decide that they don't actually like any of the new names for Wise Owl, and that Wise Owl was the best name in the first place. Let's delete all the records from the table where the family name is either canine or badger or aardvark. So to make that work, let's switch back to the Visual Basic Editor again, and then we'll copy our previous subroutine, the modify data, and then we can copy and paste that to the bottom of the module. We can then change the name of the subroutine, so it's called delete data from table using command. We'll then need to modify our command text, as you can imagine. So rather than update dbo.actor, we'll say delete from. So delete from dbo.actor. Now, as it turns out, if I just executed that statement by itself without the extra parts here, this would delete every single row from the act table, which is definitely not something we want to do at this point. So we're going to use a where clause to limit the rows deleted. We can remove the set statement from the middle there, so let's get rid of that line entirely and get rid of the extra blank line in between. Now there's a couple of ways I can test multiple criteria on the same field. I could go where family name equals cat, which, well, no longer exists now, does it? Let's change that to canine. I could then write an or keyword and then say family name equals badger, and so on for each new one that I want to test. But there's a slightly more convenient way to do this if I want to test the same field for multiple values. Rather than saying whether family name is equal to something, I can check whether family name is in a list of values. So in a similar way to passing in a list of values in the values part of the insert into statement, we can open up some round brackets, type in our first value, which is canine, And then after that, we can type in a comma. And then in some more single quotes, we can go for badger, and then another comma, and then one final value, which will be aardvark. Okay, so having done that, we can close the round brackets. We'll just modify the message box before we run the statement. This time you have deleted and num rows and records, and this should get rid of 6 records, 2 copies of canine, badger and aardvark. So let's run the subroutine at this point. I've deleted 6 records, and then if I scroll all the way back up so that I can check the results I still have left in my table, if I run my get data using command subroutine one more time, if I look back at the results, I'm now left with just wise owl. The final thing to mention now is just a tiny little bit of optimization for the sorts of statements we've just written. If we switch back to the Visual Basic Editor, of course we've written 3 statements now, an insert into statement, an update statement and a delete from statement that don't return any records. Even though they don't return records, the execution of the command is still returning an empty record set. Obviously we're not capturing it anywhere, but the reference is still returned. We can optimize the execution of a command which doesn't return any records by adding an option to the execute method. So if we head to the insert into example first of all, in the statement that says command.execute, we can type in a comma at the end of the existing line and then refer to the options parameter. We can then set this to be AD-execute, no records. So that will prevent it from returning this empty record set and provide a minor optimization to the statement. So let's just copy and paste that to our other procedures. So modify data in table. Again, this doesn't return any records. So we can paste in AD-execute, no records. And then once again to the delete example, the delete from example, let's paste that in there to the command.execute statement. So just to go through these, just to prove that there's no difference in the execution on the surface level at least, and because what we're doing here is so small, we don't really see or detect any kind of performance improvement, but there definitely is a minor performance improvement by setting this option. So I can run my add data to table using command, and I've inserted 3 records. I can then scroll down and I can modify the data in the table using command, and I've updated 1 record. And then if I scroll back down to delete data from table using command and execute that, I have now deleted 3 records. So there we go, there's a bit of information about executing different commands using an ADO command object. Hope you found that one useful. Thanks for watching, see you next time.